Geometry, Topic 3, Lesson 3, Example 3. Again, if you notice, we are on paper, which means you probably need to have a compass and a protractor. Compass, protractor, compass, protractor. You need those. Go ahead, pause your video, grab them. We're going to look at how this works. The first drummer in a drum line is at the 20-yard line, and the sixth drummer is at the 35-yard line. The drum line rotates counterclockwise 180 degrees about the sixth drummer, then rotates 135 degrees clockwise about the first drummer. If you've ever been in a marching band or watched a marching band at a football game halftime show, you have probably seen this kind of rotation. The first thing that we have to understand is that A is going to stay where he is, okay? And then we're going to be rotating 180 degrees about that. So basically, this line of people is going to be going like this, and they're going to stay in their beautiful straight line, and they're going to walk around marching until they are facing 180 degrees the other direction. So to be able to mark that on our thing, we're going to use our protractor to measure. So we are lining that up, and we're going 180 degrees, which is the exact opposite direction. So you actually would see that is straight over, right? 180, that's going to be going this way. And so if B was at 20, that is 1, 2, 3 marks over. We are now going to be 1, 2, 3 marks over. So we've rotated that 180 degrees. Another way to look at this is to see what that line actually did was move in a semicircle. And I've told you guys before, if you have trouble keeping your compass in one spot, a shortcut is to hold down the pointy part and gently rotate your paper. So you can see that what this marching band did was come around this way 180 degrees. Well, 180 degrees is pretty simple move. But then, now we have B prime over here. Now B gets to stand still, and A is going to move. Well, this time they are moving 135 degrees clockwise. Remember the first time we went counterclockwise, so we moved to the left. Now we're going to go clockwise. So we're looking here at where that is. And we have to remember, do we want the inside or the outside? So A is going to be the one moving. So we're moving clockwise. And so that means we're going to start at 0 on the outside and be moving 135 on the outside of the circle. Okay, so make sure we line up at B, because B is the part that is staying in place. And 135 degrees, we start on the outside, we move clockwise 135 to right here. And right here is where that 135 degrees line is going to be. Okay, so now we're going to come back and we're going to have our compass open from B to A. And remember, A is moving. And so I'm just going to rotate my paper in this direction to figure out where we're going to stop. And that will be right here. And this is my new A prime. So the question that they're asking is describe the change in position as a composition of rigid motions or rotations. So we want to describe the change as a composition of rotations. So remember that we are using lowercase r. as a rotation, and we reflected 180 degrees about point A. And remember, the first thing that we did goes on the right. The second thing that we did actually goes on the left. So we're going to say that then that was 135 degrees about B prime. So we started at A and did this 180 degree rotation using A as our pivot point, and then we used B prime as our pivot point and went 135 degrees. Now, because we went clockwise, we actually need to say that that was minus 135 degrees, because if we have a positive, we go counterclockwise, and a negative, we would go clockwise. Go ahead and do the try it at the bottom of the page. Suppose the drumline instead turns counterclockwise about B prime. How many degrees must it rotate so that the sixth drummer ends in the same position? So what it's asking is if on step 2, instead of rotating this way, we're going to go the other direction. So we would start here, and we would be going this way instead. So just so that you can see what we're talking about for the try it, talking about rotating this way. And how many degrees would that have to be? Well, we already know that the whole circle would be 360, and we could just subtract the 135 and get 225 degrees. So 225 degrees counterclockwise would reach the same destination as 135 degrees clockwise. Can the composition of rotations be described as rotating 45 degrees about A, since 180 minus 135 equals 45? Well, if this math is correct right here. However, if A is our pivot point, then we're going to be doing from this, the center of rotation will be different. So we would be pivoting from a different place. So your answer for B is no, because the center of rotations are different. Because the centers of rotation are different. Sorry, you can't see that. No, because the centers of rotation are different.